Way out in the middle of the Gobi Desert, something incredible is happening. A technology that the West literally threw away is being brought back to life. And we're not just talking about another power plant. No, this could be the key to solving the single biggest problem with nuclear energy. And if it works, well, it could change everything. Yeah, right here in this massive, seemingly empty landscape, China's pulled off something that a lot of people thought was impossible. They've built a reactor on a design the rest of the world basically gave up on. And what's so special about it? Well, it's a design that might just make nuclear meltdowns ancient history. But here's the crazy part. This amazing, revolutionary technology, it's not new at all. In fact, it was born in America right in the middle of the Cold War. It was tested, it was proven, and then it was buried. So why? Why would you bury something so promising? Well, get this. It wasn't very good at making material for nuclear bombs. And back then, in the thick of the arms race, that was pretty much all that mattered. So now, China's bringing it back from the dead. And trust me, the implications are absolutely huge. Okay, so let's get into it. What exactly is this revolutionary reactor? Well, it's what's called a fourth-generation design. And believe me, it basically tears up the old rulebook for how nuclear power is supposed to work. Alright, it's called a molten salt reactor, or MSR for short. Now, instead of the usual solid fuel rods that have to be cooled by tons of high-pressure water, I want you to imagine something totally different. Picture the nuclear fuel itself, in this case thorium, being dissolved directly into a liquid salt. So this hot radioactive salt mixture is everything. It's the fuel and the coolant all rolled into one. And this simple change in design, it's a total game changer. It takes on the biggest headaches of old school nuclear power head on. First, it runs at normal atmospheric pressure, which is a huge deal for safety. Second, it uses thorium, a fuel that's way more common than uranium. And maybe most importantly, it doesn't need any water for cooling. That means you can build these things pretty much anywhere. Let's talk about pressure for a second, because this is the critical difference. You think about disasters like Chernobyl or Fukushima, right? What caused them? High-pressure steam explosions that literally blew the reactors apart. A molten salt reactor, on the other hand, just operates at regular, everyday air pressure. So without that insane pent-up force, a massive catastrophic explosion like we've seen before, it's just physically impossible. Zero. That's how many gallons of water this thing needs for cooling. And that right there is another game changer. You know, conventional reactors, they have to be built near huge sources of water, like coastlines or massive rivers. But when you take water out of the equation, well, suddenly China can build these reactors in its driest, most remote inland areas, and turn places like the Gobi Desert into incredible energy hubs. But hang on. The innovations don't stop there. We haven't even gotten to the best part yet. The safety system in this reactor, this is where the design is just brilliant. It doesn't rely on complicated computers or panicked engineers hitting a button. No, it just relies on the basic, undeniable laws of physics. Okay, check this out. It's called the frozen salt plug. It sounds simple, and it is. At the very bottom of the reactor, there's a drain, and that drain is blocked by a plug of salt that's kept frozen solid by an external cooler. Now, if anything goes wrong, the power cuts out, the reactor starts to overheat, that cooler just shuts off. The plug melts, and what happens next? Gravity takes over. The liquid fuel just drains down into these specially designed cooling tanks underneath. Once it's in there, it spreads out, cools down, and freezes solid again, stopping the nuclear reaction completely. It's a totally automatic, hands-off shutdown based on simple physics. No buttons, no computers, no way for it to fail. And what about the nuclear waste? You know, the stuff that everyone worries about. Well, it's a totally different ballgame here. With traditional uranium reactors, you're left with waste that's dangerously radioactive for 10,000 years. But with a thorium fuel cycle, that radioactivity drops to safe levels in just 300 to 500 years. Now, that's still a long time, but it's a problem we can actually get our heads around. It's a solvable problem. And don't just take my word for it, experts are absolutely taking notice. As Dr. Mark Halm of the Australian Nuclear Association puts it, this unpressurized core is just an inherently safer design. It gets rid of the very failure modes that cause the accidents we all fear the most. It's a total paradigm shift. So you might think China's goal here is just to make clean electricity for the grid, right? Well, that's only the beginning. They see this technology as the engine for a whole new industrial revolution. See, these reactors run incredibly hot. We're talking around 650 degrees Celsius. And that intense heat isn't just a byproduct, it's a valuable resource. You can use it to produce hydrogen fuel way more efficiently than any other method out there. They're calling it purple hydrogen, and it could be the silver bullet for decarbonizing all those tough, heavy industries, things like steel manufacturing, cement, and chemical plants. And that ambition, it doesn't just stop at the edge of the desert. No, they're taking this technology all the way out to sea. So take a look at this. This is the Kun 24AP. It's a concept for the world's biggest nuclear-powered cargo ship. And what's powering it? You guessed it, a Thorium Molten Salt Reactor. This would let it sail for an entire decade without ever needing to refuel. And the reactor itself is designed as this sealed plug-and-play module. So after 10 years, you literally just swap out the whole unit like a giant battery. This could be how we finally decarbonize the entire global shipping industry. So what is China's endgame in all this? I mean, this kind of rapid progress isn't just for the sake of science. This is a strategic play, a push to become the world leader in energy. And just look at this timeline. It really shows you how methodical and incredibly fast they've been moving. They revived the program back in 2011. By late 2023, they achieved criticality. That's the sustained nuclear reaction. Just a few months later, mid-2024, the prototype reactor was already at full power. And the next major milestone is in late 2025, when they prove the thorium to uranium conversion. When they do that, they'll have demonstrated the entire fuel cycle works, for real. And they're not stopping there. The next phase is even more ambitious. The TMSR-LF2 is going to be 30 times more powerful than the prototype, and it'll be the first one to actually generate electricity for the grid. It's also going to test out this new power cycle using supercritical CO2. That's basically carbon dioxide that's put under so much pressure it acts like a liquid, and it lets you build these super efficient, really compact turbines. They're aiming to have this done by 2030. China is absolutely on the fast track to commercializing this tech. So why the big rush? Well, this number says it all. 20,000. That's how many years China's own domestic reserves of thorium could power the entire country. We're not just talking about clean energy anymore. This is about total, complete energy independence for thousands of years to come. So, okay, let's put all the pieces together here. You've got inherent safety, a much cleaner fuel cycle, all these new industrial applications, and the massive strategic resource. When you look at it all, it's pretty clear this is a whole lot more than just a new type of power plant. So if you're going to take anything away, let it be these key points. 1. We now have a nuclear reactor design where the worst kinds of accidents we all fear are physically impossible. 2. Thorium gives us a path to almost limitless clean energy with way less long-term waste. 3. This technology can decarbonize not just electricity, but also heavy industry and global shipping. And 4, with this, China has gone from a follower to the undisputed leader of the fourth nuclear generation, which, brings us right back to where we started. A technology that was literally born in the West, but then cast aside, has now been picked up and perfected in the East. And as the whole world is desperately searching for clean, safe, and reliable power, you just have to ask yourself, has the solution been sitting there waiting for us in the Gobi Desert this whole time? So what do you think about all this? Is China's big leap into thorium energy the answer we've been looking for? Or are there big risks we haven't even touched on? Let us know what you think down in the comments. Thanks for watching.